Calculating the total resistance of resistors can be easy, or surprisingly frustrating. Many learners understand the formulas but lose marks because of calculator errors, reciprocal calculations, or unit conversions. In this lesson with Moy Academy, you will learn how to calculate the total resistance of resistors connected in series and in parallel. We will work through practical examples step by step, including calculations involving milli-ohms and micro-ohms. You will also learn how to use your scientific calculator correctly when working with fractions and reciprocal functions. Let's get started. In the next 3 examples, we will calculate the total resistance of resistors connected in series. Remember, when resistors are connected in series, the total resistance is found by adding all the individual resistances together. If any values are given in different units, we will first convert them to the base unit of ohms before carrying out the calculation. Example 1. 3 resistors are connected in series, 10 ohms, 25 ohms, and 15 ohms. Find the total resistance in ohms. The formula is total resistance equals resistance 1 plus resistance 2 plus resistance 3. In this case, because all the values are already in the base unit, we simply add them together. 10 plus 25 plus 15 equals 50 ohms. Example 2. 3 resistors are connected in series, 2 ohms, 500 milliohms, and 300,000 micro-ohms. Find the total resistance in ohms. Given, resistance 1 equals 2 ohms. Resistance 2 equals 500 milliohms, or 500 times 10 to the power of minus 3 ohms, which equals 0.5 ohms. Resistance 3 equals 300,000 micro-ohms, or 300,000 times 10 to the power of minus 6 ohms, which equals 0.3 ohms. The formula is total resistance equals resistance 1 plus resistance 2 plus resistance 3. Calculation method 1 using scientific notation. Total resistance equals 2 plus 500 times 10 to the power of minus 3 plus 300,000 times 10 to the power of minus 6. This equals 2.8 ohms. Calculation method 2. First convert the units before adding them. 500 milliohms equals 0.5 ohms. Because milli means 10 to the power of minus 3, we move the decimal point 3 places to the left. 300,000 micro-ohms equals 0.3 ohms. Because micro means 10 to the power of minus 6, we move the decimal point 6 places to the left. Calculation using the converted values. Now add the converted values. Total resistance equals 2 plus 0.5 plus 0.3. This equals 2.8 ohms. Same answer as the previous method. Example 3. 4 resistors are connected in series, 200 milliohms, 150,000 micro-ohms, 300 milliohms, and 250,000 micro-ohms. Find the total resistance in ohms. Given, resistance 1 equals 200 milliohms, or 200 times 10 to the power of minus 3 ohms, which equals 0.2 ohms. Resistance 2 equals 150,000 micro-ohms, or 150,000 times 10 to the power of minus 6 ohms, which equals 0.15 ohms. Resistance 3 equals 300 milliohms, or 300 times 10 to the power of minus 3 ohms, which equals 0.3 ohms. Resistance 4 equals 250,000 micro-ohms, or 250,000 times 10 to the power of minus 6 ohms, which equals 0.25 ohms. Calculation method 1 using scientific notation. Total resistance equals 200 times 10 to the power of minus 3 plus 150,000 times 10 to the power of minus 6 plus 300 times 10 to the power of minus 3 plus 250,000 times 10 to the power of minus 6. This equals 0.9 ohms. I find this method more straightforward. What about you? Calculation method 2 converting the units before adding. First, convert each resistor value into the same unit. Record the converted values, and then add them together to find the total resistance. Resistor 1, 200 milliohms equals 0.2 ohms. Because milli means 10 to the power of minus 3, we move the decimal point 3 places to the left to get the result 0.2. Resistor 2, 150,000 micro-ohms equals 0.15 ohms. Because micro means 10 to the power of minus 6, we move the decimal point 6 places to the left to get the result 0.15. Resistor 3, 300 milliohms equals 0.3 ohms. Because milli means 10 to the power of minus 3, we move the decimal point 3 places to the left, to get the result 0.3. Resistor 4, 250,000 micro-ohms equals 0.25 ohms. Because micro means 10 to the power of minus 6, we move the decimal point 6 places to the left, to get the result 0.25. Now add the converted values. Total resistance equals 0.2 plus 0.15 plus 0.3 plus 0.25. This equals 0.9 ohms. Therefore, the total resistance is 0.9 ohms, similar to the result in the previous method. While entering the data here is simpler, you need to convert the values before that. In the next 3 examples, we will calculate the total resistance of resistors connected in parallel. Remember, when resistors are connected in parallel, we do not add the resistance values directly. Instead, we add the reciprocals of the resistance values and then take the reciprocal of the result to find the total resistance. If any values are given in different units, we will first convert them to the base unit of ohms before carrying out the calculation. Entering fractions. Before we work with parallel resistors, let's review how to enter fractions on a calculator. Some calculators have a fraction key that allows you to enter fractions directly. In this example, we are adding 1/6 and 1/3. Enter the first fraction, then the second fraction, and press equals, or execute, to calculate the answer. If your calculator does not have a fraction key, you can enter the same calculation using brackets and division. Both methods produce the same result, 1/2, or 0.5. Being able to enter fractions correctly is important because the parallel resistor formula contains several fractions, and you will need to work with them confidently in the next examples. A reciprocal means 1 divided by a number. For example, the reciprocal of 5 is 5 to the power of minus 1, which is equal to 1 over 5, which is equal to 0.2. Many scientific calculators have a reciprocal key labeled to the power of minus 1, which calculates this in one step. Reciprocals are essential for parallel resistor calculations because the formula uses the reciprocal of each resistance value. Example 4. 3 resistors are connected in parallel, 4 ohms, 6 ohms, and 12 ohms. Find the total resistance in ohms. Given, resistance 1 equals 4 ohms. Resistance 2 equals 6 ohms. Resistance 3 equals 12 ohms. The formula is 1 divided by the total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3. Calculation method 1. Use the fraction button on your calculator and enter 1 divided by 4 plus 1 divided by 6 plus 1 divided by 12. Then press equals to obtain the answer. The result is 1 over 2. After that, use the reciprocal function on your calculator, which is the x to the power of minus 1 button. Therefore, the total resistance is 2 ohms. Calculation method 2. This is longer and prone to mistakes and rounding errors. You could also calculate each fraction separately, then add the results and finally divide 1 by this answer. 1 over 4 equals 0.25. 1 over 6 equals 0.167. 1 over 12 equals 0.083. Adding these values together gives 0.250 plus 0.167 plus 0.083 equals 0.5. Now divide 1 by this result. 1 divided by 0.5 equals 2. Therefore, the total resistance is 2 ohms. In this example, the rounding did not affect the final answer. However, with other resistor values, rounding each fraction to 3 decimal places before adding them can lead to a slightly different result. This is why calculation method 1 is preferred, as it avoids unnecessary rounding and is less prone to errors. Example 5. 3 resistors are connected in parallel, 2 ohms, 500 milliohms, and 1 million micro-ohms. Find the total resistance in ohms. Given, resistance 1 equals 2 ohms. Resistance 2 equals 500 milliohms, or 500 times 10 to the power of minus 3 ohms, which equals 0.5 ohms. Resistance 3 equals 1 million micro-ohms, or 1 million times 10 to the power of minus 6 ohms, which equals 1 ohm. The formula is 1 divided by the total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3. Calculation method 1 using scientific notation. Enter the values directly into the fraction calculation. 1 divided by the total resistance equals 1 divided by 2 plus 1 divided by 500 times 10 to the power of minus 3 plus 1 divided by 1 million times 10 to the power of minus 6. The result is 3.5. Next, use the reciprocal function on your calculator. You can see how this works on the calculator on the left. The result is approximately 0.286 ohms. Calculation method 2 using the converted values. Resistance 1 is already in the base unit, so it remains 2 ohms. Resistance 2 is 500 milliohms. Milli means 10 to the power of minus 3, so we move the decimal point 3 places to the left, giving 0.5 ohms. Resistance 3 is 1 million micro-ohms. Micro means 10 to the power of minus 6, so we move the decimal point 6 places to the left, giving 1 ohm. Now enter the converted values. 1 divided by the total resistance equals 1 divided by 2 plus 1 divided by 0.5 plus 1 divided by 1. This equals 3.5. Next, divide 1 by 3.5, or use the reciprocal function as in my demonstration. This gives approximately 0.286 ohms. As expected, this is the same answer obtained using the first method. Example 6. 4 resistors are connected in parallel, 500 milliohms, 250,000 micro-ohms, 1 ohm, and 200 milliohms. Find the total resistance in ohms. Given, resistance 1 equals 500 milliohms, or 500 times 10 to the power of minus 3 ohms, which equals 0.5 ohms. Resistance 2 equals 250,000 micro-ohms, or 250,000 times 10 to the power of minus 6 ohms, which equals 0.25 ohms. Resistance 3 equals 1 ohm. Resistance 4 equals 200 milliohms, or 200 times 10 to the power of minus 3 ohms, which equals 0.2 ohms. The formula is 1 divided by the total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3 plus 1 divided by resistance 4. Calculation method 1 using scientific notation. Using the fraction key on your scientific calculator, enter 1 over 500 times 10 to the power of minus 3. Move back to the main calculation line and enter plus. Next, enter 1 over 250,000 times 10 to the power of minus 6. Add 1 over 1, then add 1 over 200 times 10 to the power of minus 3. Press execute, or equals. The result is 12. Now use the reciprocal function, or x to the power of minus 1 button. This gives 0.0833 ohms. Therefore, the total resistance is approximately 0.083 ohms. Calculation method 2 using the converted values. First, convert all resistor values into ohms. 500 milliohms equals 0.5 ohms. Because milli means 10 to the power of minus 3, we move the decimal point 3 places to the left. 250,000 micro-ohms equals 0.25 ohms. Because micro means 10 to the power of minus 6, we move the decimal point 6 places to the left. 1 ohm remains 1 ohm because it is already in the base unit. 200 milliohms equals 0.2 ohms. Because milli means 10 to the power of minus 3, we move the decimal point 3 places to the left. Now substitute these values into the formula. 1 divided by the total resistance equals 1 divided by 0.5 plus 1 divided by 0.25 plus 1 divided by 1 plus 1 divided by 0.2. This equals 12. Now take the reciprocal of the answer. Total resistance equals 1 divided by 12. This equals 0.0833 ohms. Therefore, the total resistance is approximately 0.083 ohms. As with the previous example, this method works well, but calculation method 1 is usually faster and reduces the risk of rounding errors. Notice that 2 of the resistor values were given in milliohms. Although 500 milliohms and 200 milliohms could be combined when converting units, we still need to treat them as separate resistors in the parallel calculation. Each resistor must have its own reciprocal calculated before the values are added together. Congratulations, you've now learned how to calculate the total resistance of resistors connected in both series and parallel circuits. We covered the key formulas, unit conversions involving milliohms and micro-ohms, and how to use your scientific calculator correctly when working with fractions, scientific notation, and reciprocal functions. Remember, for resistors in series, add the resistance values directly. For resistors in parallel, add the reciprocals first, then take the reciprocal of the final answer. Whenever possible, enter the complete calculation into your calculator to minimize rounding errors and improve accuracy. Thank you for watching this lesson from Moy Academy. If you found this video helpful, please like, subscribe, and turn on notifications so you don't miss future tutorials. Thanks for watching, and we'll see you in the next lesson.